Okay, Watkins. Now, it's come to my attention that CBA 3 needed to be moved to the 5th 6 weeks. So because of that, I've moved all the assignments leading up to CBA 3 to the 5th 6 weeks. Okay, so that's going to require you to make a new 5th 6 weeks table of contents. So if you would, let's do that now. All right, now that you have your 5th 6 weeks table of contents, we're going to start this video with Monday, February 11th, cube and cube root transformations on page 45. All right, so let's move on to the notes. All right, cubic transformations on page 45. So when f of x equals negative a, parentheses, negative bx minus h cubed plus k. The negative in front of the a reflects over the x-axis. When a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When the negative in front of the b, it reflects over the y-axis. When b is greater than 0 but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. And when it's plus h, it translates left. Minus h, it translates right. Plus k, it translates up. Minus k, it translates down. All right, so if you would finish up those notes. All right, now those notes are updated. We're talking about cubic transformations and cube root transformations. So you're going to need 2 pages of notes for this. Okay. So f of x equals negative a cube root of negative bx minus h plus k. When the negative reflects over the x-axis, I should say when the negative in front of the a, it reflects over the x-axis. When a is greater than 1, it's a vertical stretch. When a is greater than 0, but less than 1, it's a vertical compression. When the negative in front of the b, it reflects over the y-axis. When b is greater than 0, but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. When it's plus h, it translates left. When it's minus h, it translates right. When it's plus k, it translates up. When it's minus k, it translates down. You would update your notes. All right, now your notes are updated. Let's take a look at the examples. All right, the examples on page 45. Name the function, graph the function, describe the transformation, and state the domain and range. So here, this is a cubic function. Now, to graph this, we're going to need a calculator. So at this point, if you don't have a calculator with you, you might wait and watch the rest of the video when you do, okay? But we're going to go to New Document, New Document, Add Graph, not Geometry, Add Graph, and then we're going to graph that. So parentheses x minus 1 to the 3rd power minus 1. It's a little bright. Let me see if I can make it a little less bright. All right. Now you're going to press Control T, and I'm going to look for values starting at negative 10. Okay. So when x is negative 10, that number is way too small. Can't use that. Negative 9, can't use that. Negative 8, can't use that. I'm going to keep going until I can use a point. Negative 1, 9. So our first point is going to be negative 1, 9, or negative 9. Then 0, negative 2. 1, negative 1. 2, 0. 3, 7. And 4 is too big. Okay. So let me straighten that line out. Okay, so let's graph those. So negative 1, negative 9. 0, negative 2. 1, negative 1. 2, 0. 3, 1, 2, 3, 4, 5, 6, 7. Connect the points. Now, domain and range for cubic and cube root functions are always negative infinity to positive infinity and negative infinity 2 positive. It doesn't matter where the function moves, up or down, left or right. It's always negative infinity, positive infinity, negative infinity, positive infinity. All right, let's take a look at example 2. All right, so this is, again, cubic function. Okay, so again, we're going to use our calculator to graph. So on new document, no, add graph. So that's negative parentheses, x plus 1 squared plus 2, enter. Oh, tab, wait. Be careful of the mistake I just made. I put squared, but we're doing cubic, so that should be a 3. Okay, give me a second. The sun is shining bright. So let me block the sun a little bit. And this is too bright, so let me adjust this to make it not so bright. Coming into focus, haha. All right, now we're going to press Control T. And because the x on the table goes, or graph goes all the way to negative 10, we're going to start all the way at negative 10. And then I can't use that point. Can't use that point. Let me see if I can make it a little darker. I guess that's as dark as it's going to get. Can't use that point. Negative 310. So I'm going to make a table. So negative 3, 10, negative 2, 3, negative 1, 2, 0, 1, and 1, negative 6. And then that's too small. Okay? All right. So we're going to graph that negative 3, 10. So negative 1, 2, 3, 10. Negative 2, 1, 2, 3. Negative 1, 2, 0, 1. 1, 1, 2, 3, 4, 5, 6. Okay? Okay, so now domain range again are real simple. Negative infinity to positive infinity. Negative infinity to positive infinity. All right, and then I noticed, now I just caught that I missed the transformation in example 1, so we'll come back to that. But let's finish the example transformation for example 2. So reflect x-axis, left 1 unit and up 2 units. Okay. Now let's come back to example 1. So here, example 1 would be right 1 unit and down 1 unit. Okay, so go ahead and finish up example 1 and 2. All right, let's take a look at example 3. So now this is a cube root function. Now, let's make a table. And let's graph. So I'm going to come to on new document, no, add graph, 2. Now to get the cube root key, it's control this button right here. Okay. Okay, so then the 3 goes there, and then that's x plus 3 minus 1. Press Control T. Yeah, we're going to go all the way when x is negative 10. Let's see. Even though negative 11 looks like a good point, the graph doesn't go to there, so let's start it. Actually, you know what? That might actually not be a bad point. Let's start with that. So negative 11, negative 5. It's too good of a point to pass up. So I'm going to ignore all these decimals. Then negative 4, negative 3. Negative 3, negative 1. Negative 2, 1. And 5, 3. Okay, now we have our points. Let's graph them. So negative 11 goes off the grid down 1, 2, 3, 4, 5. Negative 4, negative 3. So negative 1, 2, 3, 4 down 1, 2, 3. Negative 3, 1, 2, 3, negative 1. Negative 2, 1. And 5, 1, 2, 3, 4, 5, 1, 2, 3. All right, so now we connect the points. Domain and range again, negative infinity to positive infinity, negative infinity to positive infinity. All right, transformation, vertical stretch of 2, left 3 units, and then down 1 unit. All right, so go ahead and finish up example 3. All right, so now let's take a look at example 4. All right, so we're going to grab our calculator. So on new document, no. Add graphing. Before we graph, let's make our table. So negative 3, control up key 3, x minus 1 plus 2. All right, press control T. Let's go all the way to negative 10. Doesn't work, so we can start with negative 7, 8. Doesn't work, doesn't work, doesn't work. 0, 5. 1, 2, 2, negative 1. And 9, negative 4. All right, now we have our points. Let's graph. So negative 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 0, 5. 1, 2, 3, 4, 5. 1, 2. 2, negative 1. And 9, 1, 2, 3, 4. Again, domain and range, negative infinity to positive infinity. Negative infinity to positive infinity. And then transformation, reflect x-axis. Vertical stretch of 3. Right 1 unit. And up 2 units. All right, so finish up example 4. All right, let's take a look at example 5. So again, to graph, we're going to go to our calculator. I'm going to go to on, new document, no, add graph. We're going to delete, the key to this is delete the equal sign. And then greater than x cubed minus 1. Now on this one, we want to go to menu, view, grid, line grid, because now we can graph using the grid points, okay? So it looks like I can use the point negative 1, 2, so negative 1, 2, negative 2, 0, negative 1, looks like 1, 0, and it looks like I can use the point Doesn't look like I use any of those points. Now it got blurry. Okay, but we know the shape of this is cubed. So now, almost made a mistake. This is a dashed line. So I'm going to make this a dashed line. And you know it's going to curve like that. Okay. And we see the shading from the calculator. Okay, so there's example 5. Let's take a look at example 6. So again, on new document, no, we're going to go to add graph, delete the equal sign, less than or equal to control up key 3, x minus 3, menu, view, grid, line grid. Now we're looking for good points. Now, what you can do is I'm looking at this and saying it's hard to see points. So what I'm going to do is I'm going to graph. I know the shading, but in order to get the points here, I'm going to go to Control Doc, Add Graph, and I'm just going to graph as if it's an equation. And then Control T. Now I'm going to make a table. And then we're going to start at -10. That doesn't work. -5, -2. 2, -1. 3, 0. 4, 1. 11, 2. All right, so -5, -2. So 1, 2, 3, 4, 5, down 2. 2, -1. 3, 0. 4, 1. 11, 2. Let me double check those points. Something looks different, but let's see. -5, 1, 2, 3, 4, 5, 2. That's correct. 2, -1. 1. Connecting points. And then it's shading. Now that's where you have to be careful. This graph and that look much different. So this is where you can go menu, view, grid, line grid, and then I'm going to verify these points. -1, 2, 3, 4, 5, 2. That okay, so -1, 2, 3, 4, 5, 2 works. And then 2, -1. That's where something doesn't check out. Okay. So it looks like it's actually so this is why it's always good to check your calculator with table also. I put a -2, 1. It should have been 2, -1 right here. So it seems like a frustrating thing. I know I made a mistake in the video, but this actually shows you where you can use the calculator to fix your mistakes. And so I put a point here, and then the graph actually shows me, oh, it should have been there. So that fixes our graph. So what I've just shown you is you get the table values, but it also, you could help by verifying the points with the graph. And that's what helped me because I realized this point was actually supposed to be here. Okay, and then you know from the previous graph that we shade below. And it's a solid line because there's a line underneath the inequality. All right, so there you go.